how to measure the energy change from burning a crisp. So the first thing you do is you take the calorimeter, which is the copper pot, and you put in 50 centimetre cubed of water and a thermometer, and you clamp it using a retort stand on a heat-proof mat. You need to measure the temperature of the water and also measure the mass of the crisp. You then set the crisp on fire using a Bunsen burner, holding it with tongs, and then hold the crisp underneath the water so the heat from the burning crisp heats the water. When the crisp is finished burning and it's black, you record the temperature of the water, which will be higher than the temperature at the water at the start because it's been heated by the fire from the crisp. You'll need to make a table like this: the type of crisp, the weight of the crisp, the start of the water at the temperature, the start of the water at the end, and the temperature change. So in the example I did earlier, we used an onion ring. It weighed 0.25 grams. The water had a temperature of 25 degrees at the start. After heating it, the temperature was 55 degrees, and so the temperature change is 55 minus 25 is 30 degrees C. The equation that we need to use to measure the change of the burning of the crisp is the mass of the water times by the specific heat capacity of water. You'll always be given that, it's 4.2, times the change in the temperature. You've probably come across this before in physics. It's Q equals mc delta T. If we plug the numbers in from the onion ring experiment, we had 50 grams of water. The specific heat capacity of water is always 4.2, and the change in the temperature was 30 because the temperature increased by 30 degrees C. Then the energy change of burning the onion ring was 6,300 joules. Which crisp gave up the most energy? Because different crisps weigh different amounts, we need to compare the energy released per gram to make it a fair test. So the energy released per gram of each crisp is the energy released by that crisp divided by the mass of that crisp. So for the onion ring, the energy released per gram is 6,300 joules, which we worked out on the previous slide, divided by the mass of the crisp, which is 0.25 grams, which we did at the start of the experiment, and that gives us an answer of 25,200 joules per gram.